Remember, before you get started with your notes, that we need to fill out our table of contents. So we will be completing pages 1 and 2 today, and the title is Explicit versus Recursive Functions. And I will often abbreviate function with the F of N symbol, especially like here when I don't have the room for it. And let's go to page 2. Remember to fill in your page numbers and give this page a title, Explicit versus Recursive Functions. Anytime you are watching these videos and you need a little bit more time for writing a definition or copying down a table or an example, feel free to pause the video and then come back to it when you are finished writing and ready to go on. So let's start with explicit function. An explicit definition lets you find any output, g of n for example, for any input, so any value of n that you're going to input, by direct calculation. And to help us figure out really what that means, let's talk about some examples. So f of x equals 3x plus 7 is an example of an explicit function. I could give you any value of x, let's say 2, and we could plug in 2 for x, and I could tell you exactly what value f of 2 will give us by calculating directly. So I could say 3 times 2 plus 7 would give us, what is that, 6 plus 7 is 13, so f of 2 equals 13. Another example, sometimes we will use y instead of f of x, and so this is also an explicit function because I can plug in values for y or for x. So y equals 2x squared minus 9 is also an explicit function. In contrast, we could talk about recursive functions. So a recursive definition tells you the starting point and how to calculate the next output from the starting point. So an example of a recursive function would be this example here. We're always going to start with our f of x equals, and then we'll have this squiggly bracket which tells us there are multiple parts to this definition. The first part tells us that our starting input is 0 when n equals 0. Then our starting output is 7. So that tells us exactly where we're going to start. We're going to start with input of 0, the output is 7. And the next line will tell us what we're going to do to calculate our next output. This first part of the definition, this is f of n minus 1, is just telling us use your previous output, the last output you were given. So that, in this example, would be 7. And to that 7, we're going to add 5. So 7 plus 5, and that will tell us our next output is 12. And then to get our output after that, we'd add 5 again. So 12 plus 5 would give us 17. And we would just keep going, adding 5 every single time. This definition will also tell us what values we can use for n. So this is saying after we've got our starting value, then we can only use values of n where n is greater than 0. All right, I want you to move over to page 1, and we're going to talk a little bit about the notation for recursive functions and how to fill out a recursive function. So the recursive notation, we're always going to start with the function name. So in this example, it's f of n. The f will name the function. It could be f, g, h, q, etc. Any name that you give to the function. Inside the parentheses is whatever we're using for the input. So that tells us the variable for the input. It will usually be n or x. So after the bracket, we'll have our first output, and then after that it'll say if n equals whatever our first input is. So that first line is always the first output, the first input. And the next line will always tell you the rule for the next output, and then it will tell you what all the other acceptable inputs are. All right, let's talk about an example. So This table is an example of a function we could write a recursive function for. Our inputs are 0, 1, 2, 3, 4, and 5, and the outputs are 1, 3, 5, 7, 9, 11. That tells us we can calculate the difference between each of these outputs, so each time we are adding 2 to get to the next output. And going through that process of thinking to yourself, what do I do to get to the next output, will always help you figure out what the rule is for your recursive function. So for example, let's say that we called this table m, then this function would be m of x. And we knew that our starting output was 1, and that output was 1 for the input of 0. So it's 1 if x equaled 0. To get to our next output, we took our previous output, m of x minus 1, and we added 2. So that difference table told us we were going to add 2 to that function. And that was for all x's greater than 0. So if x is greater than 0, that finishes off our function for us. That's it for your notes for today.